Welcome to week 4. We are going to be talking about rational expressions. So polynomial type expressions that are in fraction form. So 16x over 16x is an example of a rational expression because it's written as a fraction and we've got a mixture of numbers and variables. So I want you to think about this statement, 16x over 16x equals 1 if x cannot be equal to 0, or if x is not equal to 0. Is this statement true? Does this fraction equal 1? Why or why not? And why can't x be 0? Why did we have to include this note if x is not equal to 0? Think about this, why this is equal to 1. I'm sure you've heard the phrase, like anything divided by itself is 1. So we have 16x on the top and 16x on the bottom. So one thing divided by itself will always give us 1. So it doesn't matter what number we put in for x, because when we multiply the same number by 16, we're going to get the same thing on the top and the bottom. The reason why x can't be 0 is because in our number system, dividing by 0 is undefined. We can't take a whole thing and divide it into nothing. So when we divide by 0, we get undefined, or in your calculator it will say error. So the only number that won't make this true is if we put in a 0, because 16 times 0 would make the entire denominator 0. Okay. We have the rational expression here, x minus 3 over x minus 3. What does this fraction equal? And what value of x must be excluded? So if we added a little note here, this will equal something as long as, or if x does not equal what? Okay, so again, we have the same thing on the top and on the bottom. No matter what we put in for x, if we subtract 3 from that same number, we'll still have the same value in the numerator and denominator. So this is equal to 1. And this is only true if we exclude a certain number. So you think about the denominator, right? We can't, in our number system, we can't have the denominator be equal to 0. So you have to think about what x value would make this 0. The answer is 3. So this rational expression will equal 1 if x is not equal to 3. Okay. Now we have a little bit more complex rational expression. We have some operations happening in between, some multiplication. So we have z over z times x over y is equal to x over y. Do you agree with this math statement above? Why or why not? Okay, so this is a true statement, and we can ignore or almost get rid of the z over z part, and there's this giant 1 around it, because anything divided by itself will equal 1. And then we also know that 1 times anything will just produce that thing. So multiplying by 1 doesn't change the value of the entire thing. So we can simplify this to just be x over y. Okay, we have, again, a series of rational expressions all being multiplied together. So what does this expression simplify to? What does it equal? And what x value or values must be excluded? Okay, so this one, the x over x is just, that simplifies to 1. It's the same thing on the top and the bottom. So we have 1 times 1, that's just 1, times x over 3, which would just be, change the colors, you can actually see it, x over 3. And what x values must be excluded? So we have 3 in the denominator, so there's nothing in there, right? It's always going to be 3 in the denominator no matter what. So you might think, well, there is no x value that needs to be excluded, and you'd be correct for this expression. Junior year, you're going to talk about rational functions. So even though we cross these out and it's like we got rid of it, if we treated this whole thing like x cubed, which is x times x times x, over 3x squared, that's the x times x is x squared times 3. If we treated it as a rational function, even though we cross these things out, they're still part of the original function. So you would still say x can't be equal to 0. But for sophomore year, that's in algebra 2, we'll just leave it as looking at your end result, what would make the denominator 0. Okay, here's another one. What does the expression above simplify to? What x values must be excluded? So we have x minus 2 over x minus 2, same thing, top and bottom. So that will just equal 1. So what we have left over is 1 times this rational expression. So our final answer would be x plus 5 over x minus 1. And now in this simplified rational expression, we have to look at the denominator. That's not just a number. There's a variable there. So to think about what is going to make this denominator 0. So what minus 1 is 0? Well, that would be 1. So we have to exclude x cannot equal 1. Okay, what does the expression above simplify to, and what x value or values must be excluded? So one way this one, because like the ones we try to create aren't already there like they were in the previous problem. So what you could do is multiply these together. So 9 times x is 9x. And then x times 9, well, that's also 9x. You can just change the order of the multiplication. And so now we do have the sets of 1. So we have 9 over 9 times x over x. So this is 1. 9 divided by 9 is 1. X divided by x is 1. So our final answer here is just 1. And okay. What does the expression above simplify to? What x value or values must be excluded? The same thing I did before with the 9x. I'm going to change the order. So the 2m minus 5 is being multiplied by this quantity m plus 6. So we can change the order of the multiplication. It's the commutative property. Okay, this is very slow. So I am going to try something a little different. Make a little text box down here. I'm going to leave the denominator. I'm going to leave the order the same because now my m plus 6 values, or my m plus 6 binomials are stacked on top of each other. Okay, so you see now we have the separation of multiplication. We can make a big 1 with the m plus 6 over m plus 6. And what we have left is the 2m minus 5 and the 3m plus 1. So that would be our simplified rational expression. And then let's look at the denominator. It's a binomial expression. So you have to figure out what value for m would make this whole thing 0. So you're going to, this one maybe a little bit more difficult to do in your head. So you can write an equation. 3m plus 1 is equal to 0. So you would subtract 1 on both sides. And your 3m is equal to negative 1. And then divide by 3 on both sides. So m is equal to negative 1/3. But this value is what would make the denominator 0. So we're going to put a little slash through the equal sign to show what we are excluding. So this expression simplifies to this one if m does not equal negative 1/3. I'm going to rewrite the numerator because it has this squared piece. So I'm going to rewrite that expanded out. So 6 times n minus 2. And the squared means we're taking that n minus 2 and multiplying it by itself just 2 times. So n minus 2 times n minus 2. And then on the bottom, I'll have 3 times n minus 2. And then we can simplify by finding some 1s to cancel out. So we have n minus 2 over n minus 2. So that will equal a big 1. The 6 over 3. 6 divided by 3 is equal to 2. And then we have this n minus 2 left. N minus 2. And the denominator here would be a 1, since it looks like there's nothing written. So then we don't need to think about what value must be excluded. Oh, x value should be, value for n should be excluded. Junior year, you will think about what you crossed out, this n minus 2, what would make that part 0. But for now, you don't need to worry about that. So we have another rational expression and what it could potentially equal. 4 plus x over x equals to 5. Is this a true statement? Why or why not? Okay, so hopefully you said no, this is not a true statement. I'm going to put the cross out of this equal sign. So the reasoning here is this addition sign. So all that canceling with 1s that we were able to do before is because everything was written as binomials being multiplied together or monomials being multiplied together. These monomials are being added together, so we can't cross these values out. So one way you could prove this is not true is to substitute some values in here. So if you put in let's put in 2. So 4 plus 2. That's going to equal 6 over 2, which is equal to 3, not 5. It's easier to prove something's not true all the time because you just have to find one example that shows it's false than proving something is true all the time. There is one value for x that would make this true, which is if you plugged in a 1. So it may be that the person that thought this was a true statement, they crossed out the x's to get a 1 and then added 4 plus 1, which is 5. However, again, that crossing out of these x's does not work in this situation because of this plus sign. You have to be looking for things that are the same on the top and the bottom that are being multiplied by something else.